But anyway, so we looked at the different kinds of energy, and now we're going to read a passage about energy, right? So that we can learn a little bit more about the different kinds of energy that we have. So we know, we have identified chemical energy, solar energy, wind energy, water energy, nuclear energy. But let's see what else we got. So I'm
What
gonna
of the
go.
fossil? Did they use it for energy?
So fossil fuels, yeah. So that's a
Mm-hmm.
specific kind of energy, and we'll definitely talk about that too.
Mm-hmm.
All right. So we're gonna read this article here. It's the second thing that's listed in your folder. We're gonna read it here together. But it's called A Ball of Energy.
I can go to it on my folder, or
Yeah,
you
you
want
can
us to
do
stay right here?
absolutely. You can do either one, whatever works best for you.
Okay. As far as this little thing that we was going over, can I just hit post it'll submit right to you?
Absolutely. Yep.
I've not. I'm trying to escape. I can't escape to
Uh,
get
I
to.
sub I
I
submit it when I
think
find some
it's.
more energy.
I think my laptop is really acting very.
Weird.
Yeah, so I can't
Hey, Mr.
escape.
G.
It's been holding me. So
Mhm.
I'm just waiting until when we're done.
Okay.
Maybe I can
Hey,
post my.
hey, Mr. G.
Yes.
I got a question, and I feel like you should have told us this. So if you don't mind, can I just get on you about this real quick?
Yeah.
I didn't know we had I didn't know we had mechanical energy.
Yes. Yeah.
I mean, we got all different type of energy, electrical
We got a
energy.
lot of different
Light,
kinds of energy.
Yeah, like for
light,
real.
sound,
Yeah. We got a
Oh,
thermal.
lot of different kinds of energy.
you terrible, Mr. G. You can at least say something that is all these different types of energy. You better.
I didn't want to reveal too much. I only wanted to reveal
We
what
call it
you already
melts.
knew.
You
I
our
wanted
teacher, Mr. G.
I wanted y'all to discover it on your own. This is science class. Science class is about discovery, not about what the teacher tells you, right? You got to discover, you got to find out, right?
Oh my God.
Oh,
Talking
there
about
is energy
discovery.
everywhere.
We're not
Whatever we
looking.
do,
We're
it's
not
all
looking for
filled with
fossils.
energy.
There's energy in everything. You guys have to remember
Yeah.
that. There's energy in everything.
And it's
And
actually 7 forms of energy. For real, for real.
yeah, there's at least seven, and you can even go a little deeper and find a few more. But yeah, mechanical
I
energy.
definitely.
Did you know there's two different kinds of mechanical
I
energy?
got to. I got to research. I ain't gonna
Right?
lie to you, Mr. G. But I got you.
So
I got you. I'm with you, man.
so the thing is, like, we and again, all of our energy, we don't create it ourselves. It's not man-made. It all comes from something else, right? But we all need that energy to work together in order to get us moving. So we have
That's true.
chemical energy that we get from our food that allows us to turn it into mechanical energy so we can move, right? We can't move without the chemical energy turning into mechanical energy,
Oh, I
right?
got you. I got you, Mr.
Yeah.
G.
Yeah. So all of that works together. All right. So
And you want. And
yeah,
there's
go
a
ahead.
pattern that I noticed too with this energy. All
Yeah.
this energy that we name it is energy that we actually survive off of.
Absolutely. That's it. That's exactly it. Right. Yeah. And it's because we don't think about it. We take it all for granted, right? Because we just go about our days, right? We don't
Right.
really
That's
think
true.
about all the different things that are impacting us. And that's really what it's about right now, right? When you're in the process of learning or like absorbing new information, it's all about just thinking about what already exists and how you use it all the time anyway, right? So this is
Mm.
what this really is. Okay. So we have this couple paragraphs here. It's just 2 pages. So I want us just have us kind of popcorn read it. If you guys don't mind, does anybody want to start us off with the reading?
Okay. Um. Should I start? Oh no.
The
I
word
think I'm.
energy.
Yeah.
Yeah.
Who's going to go?
Are you
DeAndre, want to go?
reading? All right. Let me start.
Okay, go ahead,
Word
Jennifer.
and the word energy can mean a whole lot of different things.
Okay.
It comes in many forms, but they are all important. Energy leads life and movement to many elements of our world.
Yeah.
The word energy comes. Can you remove the okay
Sure.
mouse? Okay. Energy comes from the Greek word energia. Is
Good.
that okay?
Yeah, that's right.
Which dates all the way back to the work of Aristotle,
Good. Yep.
a famous philosopher.
hmm
The term energy is used in many different forms of study, including the natural science.
hmm
Energy is necessary in order to perform mechanical work.
Good.
The joule, is it joule?
Yep.
Okay. The joule is the international system of units. unit for measuring energy. But energy can also be expressed through other units like calorie, kilocalories, and and what
Ergs.
you say?
Ergs.
Ergs.
Good.
Each of these additional unit comes with a conversion formula to the joule.
Okay, very good. Thank you, Jennifer. So
Okay.
so we have all different kinds of energy and the units. And when it says unit, it means like how we measure energy, right? So like, you know, how we measure length or width or whatever, depends on whatever system of measurement we're using. We can measure in inches or centimeters or what have you. Those are the units. So the joule is the unit that we use to measure energy, right? So you can measure energy in what is called a joule, right? That's the unit of measurement, or you can use calories or kilocalories. So when we're counting things like calories in our food, right? Calories not only tells us how much fat and other things are in it, but it also tells us how much energy we're getting from that item, right? So calories are energy. So you need calories, right? You know, like you don't want too many calories, but you need calories in order for your body to function. When you're not consuming enough calories, you're not consuming enough energy, you're not able to do the things that you want to do, right? And when you overconsume, that's when we lead to like gaining weight, right? Because you're consuming more calories than you're putting out. That's the idea. All of the energy needs to be in balance, okay? So you can measure energy in calories as well.
Is it only 3 of us in class, really?
I'm sorry?
I'm sorry. I'm sorry. I was just looking at the number of people in class. It's really only 3 of us.
Oh yeah, we don't have a lot of people in class today. No. All right. Deontay, you want to continue for us for us on Earth?
For us on Earth, the sun is a major source of energy. This is what allows plants to grow and also influence our ocean currents. The sun loses energy by what's that? Emitting light, lending a small fraction of it to its Earth. The transfer allows us to have light which travels on a variety of wavelength. Okay. Solar energy can be harnessed to produce many things, including electricity and heat. Some believe that the solar can eliminate more harmful pollutants. I say that right?
Pollutants.
Pollutants on our Earth, resulting from energy powered by gas or coal. There are ways to capture solar energy with panels and use it for everyday tasks like cooking, heating water, to shower, and driving.
Very good. All right, so solar energy, right? That's a major source of energy. The Earth cannot be powered without solar energy. If we lose the sun, we lose essentially everything, right? Because we cannot function on this Earth without solar energy. We need the solar energy, right, to turn it into other kinds of energy. Solar energy is where the source for our electricity comes from, right? We turn solar energy into another energy, which turns into electrical energy. We harness solar energy for heat energy, right? All of these other energies depend first and foremost on the sun. Without the sun giving us solar energy and giving us light, which is light energy that we use as well, we cannot do any other kinds of energy. All right, so we depend wholly and completely on the sun, which should not be a surprise to anybody, right? But our sun helps us to do all of these things. All right, okay. And the last page, we're going to start off with a couple of paragraphs of it here. Let me zoom in a little bit. All right, Sheila, you still with us?
Yes, I'm here.
You sound really far away, Sheila.
I'm here.
I don't know what happened.
Maybe it's the mic.
Yeah, I think your microphone might be covered or something, Sheila. You sound like
you're underwater. We'll say more and more.
Yep. Go ahead.
Oh, we all the way at the top.
Yep.
More and more architects and urban planners are incorporating solar energy into their designs of homes and office buildings. These methods, which are first employed by the Chinese and Greeks, are used to capture solar energy and then provide buildings with life and warmth.
Mhm.
Solar
Solar.
power cars have been in development for a long time, and many believe that they are valuable solutions to pollution.
Mhm.
Solar energy is a clean form of energy as a wind energy captured by turbines and windmills
Mhm.
and channeled into grids. These are both
Alternative.
alternative and fossil fuels, which pollute the environment. Wind and solar energy are both renewable and clean. So, which is saying that you can also reuse that energy.
Mhm. Right,
Uh,
exactly. So the why we want to use things like solar energy and wind energy is because they renew themselves, right? We don't have to work hard to get more solar energy and more wind energy. But if we keep using fossil fuels, if we keep using coal, if we keep using oil, we have to keep refining those things every day. We have to keep pulling more of it out of the earth, right? That takes a lot of energy and work. But you just have to put up a turbine one time, and as long as the wind is blowing, you can capture wind energy, right? You only have to put you just have to put the panels on the roof, and the panels will collect the solar energy as long as there's sun, right? You don't have to do more work. You just do you just do work one time, and then the energy keeps renewing itself. And that's why we want to move to things like those kinds of energy, because they are cleaner, they're renewable, and they're clean. Well, with getting fossil fuels out of the earth makes our air dirtier and requires more work, right?
But those things, wouldn't they need maintenance, and are they not like they need maintenance and they get spoiled at the point of time, right?
So yeah, so the wind turbines have to be updated, yes, every once in a while. Just like with all technology, they would have to be updated from time to time. Your solar panels don't have to be updated, right? Normally they last for a very long time. I'm sure as
I'm
technology.
sorry, Mr. G. Can I ask you to repeat what um before you just said
Mhm.
about the what replenish yourself? You said was that
So
the wind
the
energy? Was that the wind?
so solar and wind, yeah, they replenish
Okay.
themselves. Yeah, exactly.
Solar and wind replenish themselves.
Yeah, but solar panels you don't normally have to replace quite as often at all, because they're not filled with any kind of wiring, right? They're just panels. And I'm sure as technology updates, they'll become more and more efficient. So it'll be a good idea to replace them. But it's not like the technology that's inside of them is going to deteriorate in any way. Yeah. So as long as they don't get damaged, they're fine for forever. Yeah. So that's also another thing that makes them clean. You just have to make them once, and things are good. Okay. All right, Jennifer, can you continue for us the meaning of the word energy?
Well, okay. The meaning of the word energy changes when you get into the physical science
Mhm.
of of the many forms of energy that have been defined by the physical science. One of the best known is kinetic energy.
Good.
Kinetic energy is a term related to physics
Mhm.
that describes the energy on object possesses due to motion. Measuring an kinetic energy means measuring the amount of force an object needs to accelerate.
Good.
There are several forms of kinetic energy. These include vibrational energy, or energy due to a vibrating motion, rotational energy, or energy due to a rotating motion, and translational energy, the energy due to the movement from one location to the other.
Mhm.
A good way to examine kinetic energy is by looking at a roller coaster. The car of a roller or a roller coaster reach their highest kinetic energy when they are at the bottom of a hill. But then they start rising again. Their kinetic energy become potential energy instead, which is energy an object has in relation to its position in space.
Okay, good. So let's
Okay,
pause.
can I get down?
I'm sorry?
Should I read more?
No, yeah, we can pause right here because I'm gonna talk about
Okay.
what that means, right?
Okay,
So if you
okay.
think about a roller coaster, right? A roller coaster, as it's climbing up a hill before it goes and falls again, it is building its potential energy, right? That's the kind of energy that we need in order to have better kinetic energy. So we're building kinetic energy as we climb up the hill. The steeper the hill, the more potential energy we build. Then when we get to the top of the hill, right, that all that energy doesn't immediately become kinetic energy because it has to slowly kind of fall down that hill. As it slowly falls, the kinetic energy builds and builds and builds and builds and builds and builds till it reaches the bottom of that hill. And now it's no longer in motion straight down. Now it's going to start to climb again at the next hill. So when it hits the bottom of that hill, that's the most kinetic energy you can have. And then it starts again to transfer all of that kinetic energy back into potential energy so it can begin that climb again, right? And then go through the system over and over again. So this is what we have like energy transfers over and over again. An example like a roller coaster, we see that all the time, right? But kinetic energy is the energy of motion, right? Anytime you're in motion, you're using kinetic energy. When you stop, right? You now are building more momentum so that you can move again, right?
Okay, also, look, let me ask you a question. I don't mean to cut you off. Let me ask you a question. Because I just thought about this. I didn't want to cut you off. I wanted to hear more. So, all right. So you mean to tell me if I was to per se, hypothetically saying, if I was to run up a hill, you mean to tell me I would regain kinetic energy, even though I'd be tired? I have to stop at some point and I regain that kinetic energy.
Correct. Absolutely. That's how energy works, right? I mean, like, it doesn't matter how steep that hill is, right? You're like, you're so determined to run up it. You're going to keep running. You're going to keep running. You're going to get very tired, right? And at some point you may stop, or you might not stop. You might just slow all the way down, right? But you're still moving. And then you get to the top. By the time you get to the top and you're about to come back down, what's going to happen? Your body's going to move much faster going down than it is climbing up that hill, right? And that's a result of that energy. Even though you didn't feel like you were building any energy because you were losing energy. You were losing all your kinetic energy, but you were building other kinds of energy as you slow down.
Other energy like, other energy like, let me guess, like solar energy?
So no, when you're in motion, when you're related to motion, that's called potential energy. The energy that you don't use before moving is potential energy.
Oh.
And then it becomes kinetic energy when you start moving again. Yeah, absolutely. You'll notice that like any kind of break will give you energy, but like think about it this way. If you've ever watched any sort of sports game, right? And they're following the ball, but then the ball changes direction. The ball will change direction much quicker than the person will, right? Because the person has to stop and then go back the other direction, right? And you'll see that happen. They'll be like, oh, I'm going this way. They'll go, oh, wait, now I have to stop. And that stutter, right, is because they are now transferring all that kinetic energy that they had moving in one direction. They now have to take it and turn it in a whole other direction, right? So those energy transfers have to happen for them to stop, pause, and then go this other direction, right? If the ball changes direction on them, and especially unexpectedly, right? They have to make decisions differently to follow that ball. That is
so when the ball go up in the air, what is that? What is the energy that's causing it to move from one direction to the next?
So again, it's gonna be a transfer of kinetic energy to potential energy, right? As it's climbing up into the sky. Sorry, for instance, if it got kicked up into the air, right? It is building potential energy. It's not using any kinetic energy because kinetic energy is usually motion that is coming down or.
Okay, I thought you was gonna say something about wind energy. That's all.
No. It's gonna be potential energy. So wind energy is gonna come directly from wind, right? So if you are running with,
I think Sheila trying to get your attention, Mr. G.
Oh, okay, what's up, Sheila?
No, he's even worse. We can't hear you.
She can't. I know we can't hear you at all.
Maybe you need to tell her to log out and log in again.
Maybe that might work. Do you want to Do you want to leave the meeting and come back into the meeting, Sheila? That might work. But yeah, right now we can't hear you at all. Like it's like I see
Maybe you need to text her
talking.
because she can't hear you.
No, I just texted her, so she knows that.
Oh, okay.
Yeah,
Okay.
she knows that. I texted her that I can't hear her. I can
Okay.
see you, Sheila, but I can't hear you.
You can log out and log in.
Oh,
That's
He got me
the
over this joint
problem we're
feeling like
having with
he got me over this joint feeling like I'm about to build an Iron Man suit or something.
in as much as technology is beautiful, but I tell you, we can't. This is going to frustrate so many
Yeah.
of us, like me.
Yeah. No, I get that. I understand that.
Oh.
Yeah. So if you're like, and I was saying with the wind energy, if you're running with the wind is going to help you to move faster and stronger, right? Just like if you're in a car and you're driving with the wind versus against the wind, you'll be able to accelerate faster. But you don't create any wind energy. Our body doesn't actually use any wind energy, right? We're not built efficiently enough to use wind energy, right?
I got you.
But something like a bird, of course, is going to use wind energy. A plane will use wind energy, right? It has propulsion, but it relies on the wind to go faster. So when you travel from one direction across this country versus the other, you're going to travel faster, right? Because you're either traveling with the wind or against the wind. So when you fly out to California, for instance, if you fly from DC, you're going to be flying against the wind in most cases. So the trip is going to take longer. It's also going to take longer because you're traveling. It's different hours or whatever, right? But you're traveling against the wind, so it's going to take you like, it's going to be like a 6-hour flight. But then the flight from California to DC might be like 5.5 hours because of the fact that you're traveling with the wind. The wind is going to help the plane get there faster, right? But you don't. Our bodies don't create wind or use wind energy because we're not built efficiently to do that, right? We don't have.
I got you.
But in general, what you can benefit from wind energy, but you don't create it or use it. Yeah. All right. Okay, so we talked about kinetic energy. Oh yeah. So then the next paragraph here is about the potential energy, which we hadn't gotten to yet. But right down here it says, one of the best ways to examine potential energy is by looking at a bow and arrow, right? I'm right here in this paragraph. Energy is transferred from the potential energy in the archer's arm to the bow as it is drawn back. When it is released, the potential energy in the bow is transferred to the string and becomes the energy as the arrow shoots outward. All right, so we go from potential energy, we're building all of this energy when we draw the arrow back, and then as we release the arrow, we no longer have potential energy. It now turns into the kinetic energy to move it forward. All right, the last kind of energy, and one of the most important, is like heat. Heat is another type of energy. Heat can be transferred from one body to another in a whole bunch of ways, right? The different ways are known as conduction, radiation, and convection. These are all three different kinds of heat that we use all the time. Conduction means that the heat is transferred by diffusion and collision of particles within a body due to temperature change, right? Radiation means that heat is transferred through electromagnetic waves or moving particles. And convection means that heat is transferred through the movement of liquids. All right. So conduction is like when you put something on the stove and turn the lighter on, right? If you turn that gas or that electricity on and you put it on the stove, what you're doing is using the heat from the stove and making the thing that's on the stove hot. That's conduction. Radiation is what happens when you put something in a microwave, right? You put electromagnetic waves into the food or to make it hot, right? That's radiation. Okay. And then convection is like maybe you have a child, anybody who's had a child has had to do this, right? You heat up some boiling water, right? And you get it warm, and then you put the bottle in that water to make the bottle warm because you don't want to heat the bottle up, right? Because it's going to heat up, it's going to heat up unevenly. So you put the bottle in boiling water to make the bottle warm, right? I'm sure a lot of you have done that if you have kids or like you have nieces and nephews, right? You don't put the bottle in the microwave, right? Because then you can like burn your child. But you put it in like some boiling water to get enough heat, and you take it out and you check it, right, to make sure it's heated evenly, right? But that's convection. You use the movement of liquids to make it hotter. Okay? All right. So that's heat, but heat is always associated with a process such as flow and transfer. Okay. So one of the most common uses of the word energy is in reference to food.
Mr. G, sorry to cut you off. Are you sure she like, yeah, he's still there?
Yeah.
Because I think she's still there and she's not, she can't hear. I think she's just getting frustrated. So
Yes, we can see your mouth moving, so we know what you're saying, Sheila.
do you know if you can log if you can you maybe
Yeah,
take
try
her
logging
out?
off. Try logging
Lo-
off and logging back in, Sheila.
She said she did that.
Can you take her off and then maybe she would request back again?
I don't know. I have no idea what you're trying to say. But type it in. You typed it in before. Type in what you're trying to say to me. Type it in, Sheila.
Because she's still on there, and since she's just recovering, I think it's bad for.
Yeah, type it in. Type what you're trying to say to me in, so I can try to help you. I mean, I can't do anything for your computer from my end, right?
That's what this is. It just, oh my God, it's frustrating.
I'm pretty sure the next generation of laptops is gonna be much better.
You think so? I mean, it's man-made. Even things that are made by God are still having some kind of issues.
Absolutely.
Which is human. We're still having issues. So.
Nothing is perfect.
Look, I know this has nothing to do with the class, but I just want to get this out. Is it really true? Is it really true that Biden is at 164 electron votes?
264. Yeah, he is. He's very close.
He only need about.
He needs 6 more, which is the state of Nevada. But it seems actually he's closer to getting Pennsylvania. It seems like Pennsylvania will be called sometime today. So we're going to have a new president today.
Oh, I thought he already won Pennsylvania.
No, Pennsylvania
won Arizona.
Called for anybody. It's very close. He's ahead by like less than 1%.
Mr. G, do you have a phone number? Call.
Oh, read my text.
Oh, I can hear you now. Now that you're screaming, I can hear you.
I've been screaming.
Well, I can only hear you now. I'm telling you, you're too far from the microphone or something, Sheila.
Mr. G, I can
She said read it.
But shh,
so,
Jennifer.
I'll see you next week.
Okay, you see me next week. You're leaving, you said? Okay, yeah.
Yeah, I can't even see the screen. It won't let me back in to Zoom.
So, okay, you can't see the screen.
Oh, so she looking at us. We looking at her, but she's not looking at us.
Right. So you need to go down. You need to go down in your screen on your window and try to look for the blue camera and click on it. Did you click on it? All right. All right. So here we go, Sheila. Let's try something here.
I think I need to take classes for sign language. If I just read everything she just said, I'm lit.
Okay. All right, Sheila. I'm not sure what's going on with you, with your computer.
I can see you.
Okay, you can see me?
Yeah, but on my screen it says Zoom phone is expanding your reach. Streamline global calling in 40 plus centuries of territory. What is that? I don't want that.
I have no idea what that is. I don't know why. I have no idea why we can hear you now either. But we can hear you now.
God.
We weren't hearing you before. I promise you we weren't hearing you before.
But we can hear you clearly now.
We can hear you very clearly now.
Man, I'm about to come up out of here, man, because it's irritating me.
Sorry, it's all right. It's a
So
pity.
let's see if I can get you to see the screen now. Wait, so give me a second and let me know what you see. What do you see now?
I see a little on the right hand side, a little corner with some tiny words on it, where your picture was.
Where my picture was. Okay, so click on that little corner and try to make it bigger. Like double click on it, see if that helps.
Oh my God.
Did that work?
Oh my God, Ned knocked me completely out.
Okay, it didn't knock you completely out because you're still here. I still see you. So it didn't knock you out.
I can't see you. I can't see nothing, man.
Okay, wait. Pause.
Oh my God.
Pause. We're gonna get there.
Mr. G, I see you. Well, you know what? Unconnect me or something because this is, man, it's making my leg ache.
Sorry.
I'm getting frustrated. What I gotta do to come up out of here? Put me back on or something.
So you have to leave the meeting, but if you shut your laptop down, you should be able to exit out.
Okay, it says join meeting.
No, not join. Okay. All right, y'all. Okay, we're back.
I just had to let that out. I'm sorry.
That's fine.
No, but I think she said she wants to join again.
Yeah, I mean, you know, she'll be back, I guess, when she can figure it out. I'm not sure what was happening with her laptop today or what was going on in general, but
Okay.
you know, I can't I'm not there with her. So
it's frustrating. It's like me and Kemi. It's as if sometimes in my mind I should just use the laptop and then put it on the floor.
Yeah.
And then, it's so frustrating.
Yeah.
Kemi has been so frustrating these days.
Yeah, I think the biggest issue for her too is that, you know, I couldn't hear her, right? For much of the class. I don't know what happened, what changed, but all of a sudden I couldn't hear her. And then right there towards the end, we could hear her, but it was too late, right? She was already too frustrated to try to, for me to try to help her. Okay. All right. So again, just to wrap up, energy, you also reference energy when we're talking about food energy. So that's the energy that animals and humans derive from their food. And the human body uses energy for a wide range of things, including metabolism in our organs and tissues, and to move. So metabolism means the process by which our organs use energy to do the things it's supposed to do, right? So in your heart, your heart's going to use its energy to pump our blood, right? Your lungs are going to use energy for you to breathe, all those things, right? So metabolism is whatever your tissues or organs are supposed to be doing. And yeah, so it's also the reason why when you are sedentary or you sit around a lot, you require less energy, right? I don't know about anybody else, but since we've been on lockdown, I've had to I've realized that I don't need to eat as much. And thank God I realized that. So I'm not, sitting here just gaining a ton of weight. But I only have like 2 meals a day now, right? Because I don't have to have 3 meals a day because I'm not running around the same way I used to run around, right? So it's about, you don't require as much energy when you are more sedentary, right? When you're sitting around more.
But for some people, they eat more.
But that's stress, right? That's not a requirement.
Don't do that to people. Some people can just like to eat. Yeah, that's not always.
But
stop right there.
Like me now, I've not been eating, but mine is because like when I'm stressed, when I'm not happy, I've
been thinking about 3 different type of breakfasts right now, and I'm thinking about going through with every single last one of them.
Mr. G, please, what did you talk about conduction? Conduction. What did you explain about conduction?
Yeah, so there's 3 different kinds of heat, right? Conduction, radiation, and convection, right? An example of conduction is when you're heating up a pan or like a kettle on the stove, right?
Okay.
Right? When you have a direct transfer of heat through to something else, that's called conduction.
Okay. Right? The other ones are okay.
Yeah.
Okay, thank you.
Yep, no problem.
It's basically like when you cooking and stuff, that's like
yeah.
That's conduction.
Heat.
Right, that's conduction heat. But when you're not cooking but just heating something up in the microwave, that's radiative. That's radiative.
Okay. All right, so what if you're using a heater and it's circulating something?
What do you mean, like a space heater?
Yeah.
Well,
a regular heater just to keep the house warm. It ain't even got to be the heater like you turn it on. I mean, like a heater like you plug in and you turn it on.
So like when we use our radiators, that's also conduction.
Oh.
Yeah, that's
it's like a director.
Because what you have to heat up a coil, and that coil gets hot, and that heat expands throughout the room. Yeah.
Okay.
That's conduction.
All right, there you go.
Yeah, that's conduction. All right, good. That's a good question though. All right, so this article that we just read, there are a couple questions you can answer about that in practice number 1. All right. It's pretty straightforward. Just a couple questions about what we just read about energy.
Right.
And then the next practice tells you a little bit more about energy. And that's really the one I want you guys to try to get to today, later today, after we're done, because it's a video. And you know how I feel about
Which practice 2?
practice 2. Yeah, you guys know how I feel about us watching videos together. I think it's a waste of time. I think you guys should just sit and watch it whenever you guys get a chance. So watch practice 2. It'll give you a lot more information about other kinds of energy, right? And then the other practices in here are not as important, right? So these are just there in case you were like, you know what, I'm having a good time learning about energy. So these 3 and 4 are about learning about different kinds of energy and the vocabulary. Like you can define it and do like a couple little games with it if you want to. So I'll even pull it up for you. It stays in Schoology, which is great. Like you don't have to go to another site, but you hit practice 3. And then you can choose the different ways you want to study. If you want to study using the match mode, the learn mode, the test mode, whatever. And like, for instance, you play it and then you're like, oh, what is this? And kinetic energy is what? And I have to find the definition of it or whatever. And it just like tells you, and as you get better at it, it tells you that you're increasing your time or not. But anyway, that's just a practice if you want to learn more about the vocabulary. So 3 and 4 are essentially the same. One is just.
So I got one more. I got one question. Since you told us to like watch the video, well, you want us to do one, and you want us to watch the video like independent. So I got a backwards question for you.
Yeah.
How about if we watch the video and then do the question? Would that help us in any way? Be honest.
No, honestly, I don't think it will, because practice number 1, like I'll even pull it up for you. Practice 1 is like 3 questions on this article that we just read. It's 5 on this article. We just that video is not going to help you at all, right? Because that video is not related to the article that you just read. I like, you don't even have to do practice 1. I really want you to do practice 2. That's the thing. Practice 2 is what I need you guys to do. And
so
then
as far as practice 1, how do we answer those? You know, like, do we answer those like? Do we have to circle them, or do we have to write out our answers?
So you don't have to write out the answers. So what you can do, I think the easiest way, because like I know that Jennifer and I have had this conversation before. It's very hard for you guys to go from this to submitting your answer, right? Because you have to click the submit button over here on the right, and then you lose the questions, right? So what I would do is I would go into Schoology, I would take a picture of this screen, right? And then click the submit button, and then say, oh, well, number 1 is A, 2 is B, 3 is, then that, you just put your answers in that way. Right, so take a picture with your phone and then put your answers into the submit button. I don't want you to circle it or anything like that. I just
you want us to take a picture on our phone?
Yep, and then click the submit button, because when you click the submit button, you're going to lose the questions. Right, and then you can answer the questions by going, number 1 is A, number 2 is B, you know, whatever, like that.
Right. All right. Yeah, I got you.
I don't need you to write the whole question.
Use our cameras.
That is what I do now. So these are what we're going to do by ourselves.
Yeah, exactly.
Okay.
So just practice number 1. If you get to it, that'd be great. I really want you to watch the video for practice number 2 and learn a little bit more about that. All right.
Okay.
And then if you want to, practice 5 is about light energy, which is just another video to watch. And then there's a couple of questions about what light energy is. This one, again, is not important. I really just want you guys to focus on 2. And if you want to, also number 1.
Okay.
But yeah, so the idea here today is that what you should be walking away with is that energy comes in different forms, right? But we don't create energy. Energy is always transferred from one kind of energy to another kind of energy.
Right, but we didn't do this earlier where you stopped at like what are the different type of forms of energy. We did that already, right?
No.
Oh.
I don't think so. Did we?
You're talking about energy.
Yeah.
No, yeah, well, I was just talking like where his little fingertips stopped there, like what are the different type of forms of energy?
Yeah.
Like a lot of times when he do something, I be in my own folder making sure I do it too.
Oh, okay. Okay.
Yeah.
The discussion question.
Yeah.
Right. Yeah.
Yeah, I think we need to do that.
Yeah, we talked about this already this morning, right? Yeah, we did that. We read the article, which was the second thing, right? And then practice number 1 is just questions about this article. And then practice 2 is a video. Okay.
Okay.
Just to recap what that was today. So yeah, so we just, we learned a little bit more about energy. And I think that's going to be helpful for us because next week we're going to talk about Let me make sure I have it in there. We're going to talk about alternative energy, right? Look, we talked about it a little bit today, the idea of focusing on using things like solar and wind. We're going to talk about why it's important to use alternative energy to mitigate, right? Which is to prevent the effects of climate change. So when we use those alternative energies, the idea is to help us mitigate what could be the effects of climate change.
Okay.
All right. So I hope what you guys are going to do today is when I release you all in 2 seconds, you're going to go in the Schoology, click on practice 2 and watch this video, and not do what Mr. G is going to do, which is release you all and turn on the news and right. Like I need to stop. Like I need to like pull myself away from the TV, but I can't. It's like the end of a really bad movie. You're like, I just need to know, did people survive or not? Did they what happened? Right? So I have to now watch all the way to the end. But I don't encourage you guys to do that. I encourage you all.
We have a lot of work to do.